Okay, thank you. Then this is all about fatty acid. Then we talk about important fats. Here I told you protein is completely made up of amino acid, carbohydrate is completely made up of monosaccharide. But in fat, with fatty acid, there is one another molecule present, and this molecule can be anything: glycerol, phosphorus. This molecule decide the type of fatty acid. First we describe triglyceride. Triglyceride are more abundant fat of our body in nature. Most of the fat is present in the form of triglyceride, and in triglyceride a glycerol, this is a structure of glycerol. Three ends are there. It will be connected to three fatty acids. So triglyceride, tri means three and glycerol means glycerol. In this three fatty acid attached to one molecule of glycerol. So it is structure of triglyceride. Don't get confused like there will be three glycerol molecule or three fatty acid molecule. There will be only one glycerol molecule and three fatty acid molecule attached to this glycerol. Okay, phospholipid. In phospholipid, other than glycerol, phosphoric acid or
Sir, what
phosphorus.
is the structure of fatty acid, sir?
Okay, structure of fatty acid. This is structure of fatty acid. This one.
Okay. Methyl group and carboxyl.
Yeah, methyl
Carboxyl.
group and carboxyl group. And in this methyl group, this is methyl group. In this methyl group, if there is a double bond, then we
Yeah,
will.
then it is unsaturated. If there are all single bonds, then it is saturated.
Yes, yes. Okay, next, phospholipid. In phospholipid, there is phosphoric acid and a nitrogenous base other than glycerol. So we don't need to take phospholipid in our diet because our body makes it when we need phospholipid. Phospholipid has very much important function in our body that are also very much important for examination. First one is it takes part in fat digestion, digestion of fat. Next, it also take part in carry lipid particle across the cell membrane in the bloodstream. Like this is our gut or GIT, gastrointestinal tract. This is our blood vessel. So phospholipid only help to transport fat molecule from GIT to this blood vessel. And phospholipid is also helping in digestion of fat. So digestion and absorption of fat is carried out by this phospholipid. Phospholipid is also an important component of active tissue, and most important, phospholipid are present in our cell membrane. Phospholipid are present in our cell membrane. Then cholesterol. Cholesterol, as I told you, is the essential part of each and every cell of our body, and cholesterol is precursor of many hormones. And I also told you to make a list and some vitamins like vitamin D. Vitamin D, how vitamin D is formed? Vitamin D is formed from this cholesterol only. The name of that cholesterol is 2-hydro, sorry, 2-dehydrocholesterol. This 2-dehydrocholesterol, when sun rays fall on this cholesterol, it changes into vitamin D. Although this is a very complex reaction in which many intermediate substances are present, but in short, this 2-dehydrocholesterol, when sunlight falls on this cholesterol, it changes itself into vitamin D. So cholesterol is also present in our heart, liver, kidney, and embryonic stage. When we are in embryonic stage, like in fetal stage, then also this cholesterol content is very high. Next, bile acid. Bile acid are released by uh, our liver and stored in gallbladder. The bile acid are also formed from cholesterol. So this is all about cholesterol. I told you about two type of cholesterol, high density cholesterol and low density cholesterol. This is also known as high density lipoprotein and low density lipoprotein. Are you having any confusion in this? High
No,
density.
sir. Low density is having saturated fatty acids. High density has unsaturated fatty acids.
Yes, and low density cholesterol, it is bad for our heart because when it travels in our blood vessels, it gets accumulated in blood vessels and slowly it form a thick layer inside blood vessels and it leads to blockage of blood vessel, and this disease is known as atherosclerosis. Atherosclerosis, atherosclerosis. It is also known as coronary artery disease or coronary heart disease. So when it will be get accumulated, it will start blocking our blood vessels. So this LDL is very much harmful for us. And what this HDL do, high density lipoprotein, it tends to open this blockage. So it is good for our heart. Next one is lipoprotein. So here is our new topic, lipoprotein. So as phospholipid and all lipoprotein are also synthesized in liver. Most of the important things for our body, they are synthesized in liver only. They are composed of 3/4 to 2/3 lipids and the remainder protein. Okay, what this line mean? This line means that lipoprotein comes in both lipid and protein, because this is conjugation of lipid and protein, means lipid are joined with protein. Next, the thing is why lipid and protein they make conjugation. It is because just imagine a water pipe, and you want water is flowing in this pipe and you want to transport some oil droplets through this water pipe, then it will be not possible because oil will not dissolve in this water. Oil will just float on the surface of this water pipe. Because of fat are not soluble in water, fat do not dissolve in water. So if just fat will be present in this water pipe, or we can say in our blood vessels, blood is present, blood is 70 to 80, or we can say up to 95% blood is a form of water. So as fat is not soluble in water, so it is impossible to transport fat in the blood. So for this, what our body do, this is fat, and around this fat, body will make a layer of protein. Now what will happen? This protein will get dissolved in the water, and with the help of this protein, this lipid will be transported to each and every part of our body wherever it is needed. So why this lipoprotein are being created in our body? For transportation of fat. It is a vehicle to transport fat from one part of our body to other part of our body. Is it clear?
Yes, sir.
Okay. Okay, next are essential fatty acid. Like as we have discussed is a structure of fatty acid. So fatty acid are classified into two categories, saturated fatty acid and unsaturated fatty acid. But if we talk about specific fatty acid, so specific fatty acid, there are many fatty acid present in nature. Among those fatty acid, two are very much important, omega-6 fatty acid and omega-3 fatty acid. These both are polyunsaturated fatty acid, PUFA. Omega-6 and omega-3, these both are polyunsaturated fatty acid. And why these are called essential fatty acid? Because these are not synthesized in human body, and it is very much important to include these fatty acid in our diet to avoid deficiency of these two fatty acid. So these two fatty acid, omega-6, and please try to remember name of these fatty acid. There is a slight difference in name of these two fatty acid. Omega-6, this is known as linoleic acid. Linoleic. In Hindi, we can write it as leic, L-E-I-C. And this is linolenic. This is linoleic and this is linolenic. Omega-3 is known as linolenic. Please try to remember this because many times the question is asked by this name. Linolenic means omega-3 and linoleic means omega-6. So these are having very much important function in our body, and these are only available through diet. Our liver cannot produce these fatty acid. So what are some important function of these two fatty acid, omega-6 and omega-3? These two fatty acid are so much important for our body that we cannot write all the important function of these two fatty acid because they are involved in almost every reaction in our body. But some of the important function these essential fatty acid have, they are essential for growth in young and maintenance of normal healthy skin. Essential for growth means in deficiency of these two these two fatty acid, a normal child cannot grow. And for maintenance of normal healthy skin, these two fatty acid are also very much required. That's why there are many moisturizer and lotion in which they advertise, like in our lotion, these omega-3 and omega-6 are present because these are also very good for our skin. Next, these ensure the permeability to water and other small molecule. Means in absence of these two fatty acid, omega-6 and omega-3, our cell cannot absorb water and other small molecule, means glucose also. So glucose and water, these two things can be absorbed with the help of these essential fatty acid by our cell membrane. These are also precursor of eicosanoids. Eicosanoids is a class, like it's a class in which some substances are present that are important for function of our heart. So these are precursor of eicosanoids. That's why these omega-3 and omega-6, these are also considered very good for our heart. First reason, these are polyunsaturated. So as they are polyunsaturated, they are automatically good for our heart. Second one is these are also precursor of eicosanoids. Eicosanoids is a class of chemical compound, is a class of substances that are good for our heart, that regulate vascular function. Vascular means related to our heart. Okay, next, out of this omega-3 and omega-6, omega-3 is having more function, like both are important, but out of this omega-3 and omega-6, omega-3 is more important. Omega-3 fatty acid is made up of two compounds. First one is DHA, docosahexaenoic acid, and EPA, eicosapentaenoic acid. No need to remember name of these two, DHA and EPA. You just have to know, like omega-3 fatty acid has important role in fetal brain and eye development. And these acid also protect against rheumatoid arthritis and cardiovascular disease. So these are having many function. No need to remember each and every function of omega-3 and omega-6. Just you have to remember the nomenclature like linoleic and linolenic acid. And other one is this one, like these ensure permeability to water, healthy skin. and eicosanoid. These are precursor of eicosanoids. Okay. Next, digestion and absorption of fat. So let's talk about digestion and absorption of fat. Unlike carbohydrate and protein, is it too fast? Are we going too fast?
No, sir.
Okay. If you feels like we are going too fast, then please let me know. I will check my speed then.
Sure, sir.
Okay. Okay. So digestion of fat and starts in stomach. Actually, the digestion of fat is more complex process than carbohydrate and protein. What happens with carbohydrate and protein? Just carbohydrate react with enzyme. Any enzyme will be there. Carbohydrate will react with enzyme and it will be broken down into monosaccharide or disaccharide, whatever it be. But can fat directly react with enzyme? Is it possible?
No, no, sir.
Yes, so why not?
Probably because of the fatty acids. Fatty acids don't immediately react with the enzyme.
And the reason behind fatty acid are not reacting with enzyme because it is oil, fat, and enzymes are like they are water soluble. They comes to class of water soluble compound. So you can understand enzyme as a type of water, not proper water, but those are water soluble, so having property of water. And here fat, we have oil. So what will happen if you try to react water with oil? If you try to mix some oil droplets into a glass of water, it will not
True.
dissolve, not react. So in order to react this oil with this water based compound means enzyme, our body perform a special mechanism, and this special mechanism is known as micelle production. So let's understand this process. Emulsification of fat is also known as this micelle production. So what will happen? The digestion of fat starts in stomach where a coarse emulsion forms due to churning action. Our stomach do a churning action. Churning action means our stomach, walls of stomach have movement like this. Circular movement our stomach do, and because of this churning action, a emulsion forms. Means emulsion means fat will be broken down into small fat droplets. Then the entry of fat in duodenum, the first part of small intestine, stimulates secretion of bile from gallbladder, and the next job is done by these bile acid. Okay. First, the fat is being broken down into smaller fat droplets with the help of churning movement of stomach, and then these fat droplets are being emulsified with the help of bile acid. How these bile acid are working? This bile acid, just like lipoprotein, this bile acid will be attached to membrane of this fatty acid so that it will be get dissolved into enzyme. It will be then react with the enzyme. Okay, again I will explain this. First, a fat will be broken down into fat droplets, not fatty acid. Fat droplets means just a fat is physically broken down into small droplets. These droplets will then react with bile acid, or we can say not properly react, will be just attached to bile acid, and bile acid will surround these fat droplets so that they are now ready to react with enzyme, react with water-based enzyme. This process is known as emulsification. And this compound, these fatty acid surrounded by bile acid, these are known as micelles. Again, I will repeat, these all process broken down of fat first into fat droplets, then surrounded by bile acid to form micelles. This is known as emulsification of fat. And this emulsification of fat is very much important to broken down of fat into, these are fat droplets, and then these micelle will react with lipase. So the enzyme that actually break down this fat into fatty acid, the enzyme name is lipase. Then lipase will work on this micelle and broken down into fatty acid. So last time I will repeat. First, fat will be broken down into fat droplets. These are not fatty acid, these are just fat droplets. These fat droplets will be surrounded by bile acid, and this structure is known as micelle. This process is known as emulsification, and then this micelle will be broken down into fatty acid with the help of lipase. And this lipase is being secreted by pancreas. So it is pancreatic lipase. Next, it is very simple. This fatty acid, this fat will be broken down into its respective fatty acid. If there is triglyceride, then what will be the product? If triglyceride will react with lipase, or if lipase will degrade this triglyceride, then what will be? Yes, three fatty acid and one,
Glycerol.
yeah, one glycerol. So according to the fat, it will be degraded into respective molecule, whether it will be fatty acid, whether it will be glycerol. It can be phospholipid. So then phosphoric acid will be here. So this is digestion of fat. This emulsification is important in digestion of fat. Okay, next we will discuss about RDA, recommended dietary allowance for fat. So the recommended total energy of fat is around 20 to 35% of energy. So now it is very much important, as we already discussed, 50 to 60% of energy should be from carbohydrate, 20 to 35% of energy should be from fat, and remaining 10 to 15% of energy should be from protein. So the recommended for total fat is 20 to 35% of energy should come from fat. The total fat intake is slightly higher for children. As I already told you, for children, for growing children, many fatty acids are especially required. Omega-3, omega-6, cholesterol, these are very much required for growing children. So if we talk about growing children or age 4 to 18, the fat intake is slightly higher, means the upper value is almost same, but the lower value is around 25 to 35%. So as an average, you can consider 20 to 35% fat requirement for everyone. And for children, for 4 to 18, for growing children or adults, it is slightly more required. And the children ages 2 to 4 having recommended intake 30 to 40. So what we can conclude here, as we grow up, the fat requirement decreased. The toddler means age 2 to 4, they are having the most fat requirement. Then less than these children, age 4 to 18, they required fat, and less than these adults required fat. So this question can also be asked like this you have to be clear. And the concept behind this is like growing children needs fat, and in while they are in fetus, while they are toddler, their brain, their nerves, for development of brain and nerves, they need fat. Okay, so is it clear? Fat requirement is clear.
Yes, sir.
Yes, sir.
Okay, now let's talk about saturated fat. So saturated fat make no more than 10%, like 20 to 35% is normal fat requirement. So in this 20 to 35%, only up to 10% should comes from saturated fat. If it would be greater than 10%, then we will start developing heart disease, then it will be start blocking our arteries, and the remaining 10 to 25% should come from unsaturated fat. So this is all about fat. Just 1 minute. Okay, sorry. Okay, so 20 to 35% is our daily fat requirement. Only up to 10% should be comes from saturated fatty acid, and the remaining 10 to 25 should comes from unsaturated fatty acid. So this is our fat requirement. One more thing was there, like as we grow up, our fat requirement decreased. So it is all about fat. So please revise all these concepts. The question will mostly be asked from the fat requirement, emulsification of fat, and function of each and every fatty acid, like function of cholesterol, phospholipid, triglyceride, poly and unsaturated, saturated and unsaturated fatty acid. Question will be probably be asked from these topic. So is anyone having doubt in this fat or fatty acid? Is there any doubt?
No, sir.
Sir, is it cholesterol is the precursor of insulin?
Not insulin. Insulin is a peptide hormone. Two types of hormone are there. First one are peptide hormone, other one are steroid hormone. Peptide hormones means this insulin, glucagon, and thyroid hormone. These are peptide hormone, means they are made up of amino acid. So cholesterol is not precursor of this peptide hormone. Amino acid will be precursor of this peptide hormone. Steroid hormone like testosterone, adenocorticotropin hormone released by pituitary. These all are steroid hormone. So cholesterol is a precursor of these all steroid hormone.
Because in last test there is a question about cholesterol is the precursor of. The answer was the insulin.
Answer was insulin. Okay, I will check that question. Can you please send screenshot of that question if
Okay, I
you
will
have?
try, sir. Yes, sir.
Okay. Okay. But in real, cholesterol is not precursor of insulin. I think there will be some mistype or something. I will check. Thank you. Okay. Any other doubt?
No, sir.
No, sir.
Okay, now next vitamins and minerals. As I already told you in starting, vitamins and mineral you will have to read or study different types of compound here, like how the classification is done. First, all the similar compounds that provide energy are placed in carbohydrate. Next, all the compound having similar structure made up of amino acid, they are placed in protein. And these are maintaining framework of our body. All the compound, those are made up of fatty acid. Those include oils and lipids that are included in fats. The remaining compound, except of whatever their structure is, whatever their function is, they are placed in vitamins and minerals. all the other remaining compound. So all these vitamins and all these minerals don't have a specific structure, don't have a specific function. They have varying type of structure, varying function in our body. And out of these vitamins and minerals, those are present in earth crust. Those we can directly take up from earth crust. Those are placed in minerals, whether it is iron, whether it is calcium, and the other class, those are not present in earth crust. Those are being prepared by any living entity, whether it is plant, whether it is animals. Those are known as vitamins. So all the remaining nutrients that does not comes under carbohydrate, protein, and fat, they are included in vitamin and minerals. So don't try to conclude vitamin and minerals like these are having a structure like this, these are having structure like this. They don't have any proper structure, they don't have any proper function. We will just study the most important function of vitamins and minerals. These vitamin and mineral having hundreds of function in our body which we cannot count. So we will just try to remember the most important function of each and every vitamin, each and every mineral. And in UGC NET, there will be no deep question from this vitamin and mineral topic, because they know also to study this vitamin and mineral in detail. It will take around a complete course only, because these are having so much structure, these are having so much function. So let's start with vitamin and mineral. A most important point is that they are having almost zero calorific value. So can anybody explain this? What does this zero calorific value means?
So most of the food that we take, like the macronutrients which come from carbohydrates, proteins, and fats, comprises of calorific value, which is like per gram intake, there is some kilocalories of energy that it gives.
Yes, very good.
But when there is zero calorification, it does not contribute to any calories in the body.
Yes, very good. So zero calorific value means they are giving 0 calories per gram, means they are not providing any energy to our body. Vitamins and minerals, they are having 0 calories. Can you name one more nutrient having 0 calorific value?
Nutrient, you said in the earlier classes, you said it's water and fiber.
Yeah, water and fiber. Very good. These are also having zero calorific value. So vitamins and minerals. Actually, I just remember once UGC asked this question, which of the following have zero calorific value? So they just name some compound like sucrose and fructose, and one was like vitamin D. So any vitamin that will have zero calorific value. These does not provide any energy to our body. Even minerals do not provide any energy to our body. But they are very much important in human diet because they promote growth and optimum health. Without these vitamins and minerals, we cannot survive, and their deficiency is very much high, because most of the time we focus on carbohydrate, we focus on protein, we focus on fat, and in our natural diet, carbohydrate, fat, and protein, that are those nutrients are present, but vitamin and mineral we mostly miss. So most of the deficiencies in this world are because of vitamins and protein. So a most important way to cover up this vitamin and protein in our body is to have seasonal fruits and vegetable. This is the, because you cannot make a list like vitamin D is present in this, vitamin A is present in this, vitamin B is present in this. Our body is like work like if you take all the seasonal fruits and vegetable, if you regularly consume seasonal fruits, seasonal vegetable, then your body will not need any vitamin supplement. But you should take these in a adequate quantity, like you should have adequate quantity of vegetable, adequate quantity of fruits. But after some time, we will discuss some of the major sources of each and every vitamin. Okay, now classification of vitamin. One more thing, these vitamin and minerals, these comes under micronutrient. What does this micronutrient means?
Very small quantities of those nutrients are needed.
Yes, this term is very much important. Quantity means these are required in very small quantity. This is not like these are not important. These are very much important, but these are required in very less quantity. Okay, so one more important classification is there: water soluble vitamin and fat soluble vitamin. Water soluble vitamin are those vitamin which are soluble in water. So these vitamins are stored in our body in a water source, because these are soluble in water. So what is the source of water in our body? What is the main watery compound in our body? That is blood. So most of these vitamins, they are present in blood, and because of they are water soluble, they cannot be stored in any other compound. So what happens when these vitamins are present in our body in when these vitamins are present in more quantity than they are needed, like they are present in higher amount, then what will happen? The blood will pass through our kidney, and kidney will eliminate these water soluble vitamin. Two vitamin are water soluble vitamin, vitamin B and vitamin C. So water soluble vitamins are those vitamins, those are soluble in water, those are present in blood every time. So the important point to remember in this water soluble vitamin is that our body cannot store these water soluble vitamin, because once these water soluble vitamin are present in a greater amount than it is required in our body, our kidney will eliminate the extra vitamin B and vitamin C. So we cannot store the vitamin B and vitamin C in our body. Next vitamin are fat soluble vitamin, that are soluble in fat but not in water. So these fat soluble vitamin are soluble in fat but not in water, and they can be stored in our body fat. Adipose tissue is a type of fat present in our body, which is present just beneath our skin and in surrounding of every organ. A layer of fat is present. We call this layer as adipose tissue. So fat soluble vitamins are stored in our body in fat cells, and these vitamins are all the vitamin except vitamin B and C. These are vitamin A, vitamin D, vitamin K, and vitamin E. These are fat soluble vitamin. Okay, now two questions arise here. Toxicity.
So it is A, D, K, and E, right?
Okay, sorry. Yes, E. ADKE. You can remember is a DECA, DEKA. DECA. These are fat soluble vitamin. Now, two questions arise here. Toxicity of which group of vitamin can have, or deficiency of which group of vitamin can have. I will explain what toxicity is. Toxicity is if you require something in a specific amount, but your body have that thing in a very high amount, then it will be fatal for your body. It is known as toxicity. Means presence of any substance in higher concentration than it's needed. Deficiency, you all know. So which group of vitamin can have toxicity in our body, and which group of vitamin can have deficiency in our body?
Water
Fat
soluble.
is toxic.
Fat will have toxicity. Vitamin water soluble will have deficiency.
Deficiency.
Yes, very good. So toxicity means these fat soluble vitamin can have toxicity in our body. If we are continuously taking these or vitamin A, D, vitamin K, vitamin A, E, and if these vitamin are continuously stored in our body, then they can lead to toxicity. That's why if you are taking supplement of any of these vitamin A, vitamin D, vitamin K, vitamin E, then you should take in a very specific amount. You should not take just by yourself. You should take by prescription by some qualified doctor, or you should, if you are taking it by yourself, then try to minimum maintain 1 week of gap after every 3 weeks. Many people, they just intake take vitamin E, they take vitamin D. If you are taking supplement of these fat soluble vitamin, keep remember that you should take gap for at least 1 week after taking these vitamin for 3 weeks. Water soluble vitamin are very much prone to deficient in our body, because these are not stored in our body. And what will happen if once we are not taking vitamin B and vitamin C, it will ultimately lead to deficiency. So vitamin B and vitamin C are most commonly deficient vitamin in our body. That's why taking these vitamin daily is very much important. If a single day, if you miss vitamin B and vitamin C, on that day these two vitamins are deficient in our body. So many symptoms like dry skin and dry lips and mouth ulcer. These all are common symptoms that we experienced almost every second day. Dry skin, dry lips, mouth ulcer. These symptoms are caused because of vitamin B and vitamin C. These are primary symptoms of a deficiency of vitamin B and vitamin C. These are indication of our body that we need vitamin B and vitamin C. So vitamin C you can take from any citrus fruit or curd or something. And vitamin B is present in most of the dairy items. We will study it later also. But this vitamin B, most of the people, those are having symptoms like dry skin, dry lips, mouth ulcer, or acidity. They can take vitamin B complex capsule. This anybody can take, because it will not lead to toxicity, or it will not lead to higher concentration of vitamin B. So vitamin B complex capsule, you can get it from your neighborhood medical shop, or many general store. They also sell this vitamin B complex capsule, because these capsule are very much like taken up almost by everybody, because most of the people have this vitamin B deficiency. Okay. So right now scientists know that there are 13 vitamins, 4 fat soluble vitamin and 9 water soluble vitamin. 4 fat soluble vitamin are D, E, K, A. 9 water soluble vitamin, one is vitamin C, and other one are forms of vitamin B, like vitamin B1, B2, B3, B5, B6, B7, B9, B12. These are vitamin B form. One more thing is, these all are vitamin B1, B2, B3, B5. It does not mean they are having some common structure, common function. It is not like that. These all are having different function. These all are having different structure. So right now we will stop here, and for tomorrow, if you will get free time, then try to remember the scientific name of all of these vitamin. It is most important in this chapter, vitamin and minerals. Many time, most of the time, question will be just asked from this scientific name. Even they will ask from some other topic, they will just give scientific name there. So it is very much important to remember these scientific name. I will repeat: vitamin A, retinol. You can remember it by vitamin A, retinol. Why we call this as retinol? Retinol, it is made up of a pigment retinal. This retinal is a orange color pigment. This retinal is orange color pigment that is found in orange color vegetable like carrot and pumpkin and all. So that's why this vitamin A is known as retinol. Vitamin D, cholecalciferol. Vitamin E, tocopherol. Vitamin K, phyloquinone. This menaquinone is not that much popular. Most of the time, they wrote phyloquinone for this vitamin K, or you can just remember this quinone. If you are having confusion in both of these two names, you can just remember quinone. So again, vitamin A, retinol, vitamin D, cholecalciferol, vitamin E, tocopherol, vitamin K, phyloquinone. These all are fat-soluble vitamin. Again, I'm repeating: vitamin A, retinol, vitamin D, cholecalciferol. Vitamin D helps in absorption of calcium. So vitamin D is cholecalciferol, vitamin E, tocopherol, and vitamin K, phyloquinone. This vitamin C, as it is being extracted from citrus fruit, so it is a type of acid, ascorbic acid. So you will find only one acid in all these vitamin, that is vitamin C, ascorbic acid, and some of this vitamin in this vitamin B. So vitamin C, ascorbic acid. Now this vitamin B1, thiamine, vitamin B2, riboflavin, vitamin B3, niacin, vitamin B5, pantothenic acid. Vitamin B6, you have to only remember this one, pyridoxine. Vitamin B7, biotin, very much important for our hairs. Vitamin B9, folate or folic acid. Vitamin B12, cyanocobalamin. Okay, once again, I am repeating: vitamin B1, thiamine, vitamin B2, riboflavin, vitamin B3, niacin, vitamin B5, pantothenic acid, vitamin B6, pyridoxine, vitamin B7, biotin, B9, folic acid or folate, B12, cyanocobalamin. And today, try to remember names of all these fat soluble and water soluble vitamin. Then in tomorrow's class, we will try to finish this vitamin, water and minerals, and we will try to finish this diet and nutrition by 10th. And in next 10 or 15 days, we will try to finish environment and logical reasoning also. How much environment syllabus you have covered till now?
Sir, until sustainable development goals.